This is 4-6 triangle congruence. Let's take a look at the warm-up problems. Use the diagram at the right for questions 1 and 2. What are sides AC and BC called? Those are legs of the right triangle. Side AB is the hypotenuse. The hypotenuse is the one that's directly across from the right angle. Which side is between angle A and angle C? That would be side AC, segment AC. Now, this has nothing to do with the image. Given triangle DEF and triangle GHI. Let's draw it out. DEF and GHI. We're saying that D is congruent to angle G despite my drawing, and angle E is congruent to angle H. Why is F congruent to I then? If those two angles are congruent to each other, how can we know for sure that F is congruent to I? Well, that was something called third angles theorem. So we definitely know that F is congruent to I. And I can give you an example. So say this one was 30 and this is 80. Then this one would be 30 and that would be 80, right? So far for this triangle on the left, we've used 110 degrees. So how much is left for angle F? Well, that would be 70 because the triangle sum theorem says they add up to 180. Same thing, in the triangle on the right, we've used 110 degrees. So how much is left for this angle? Well, again, 70 because of the triangle sum theorem. So if two of them are congruent to each other, the third must be congruent. An included side now. Before we had an included angle, which was in between two sides. An included side is in between two consecutive angles. So PQ is the included side of angle P and angle Q. Because now we're going to talk about angle side angle, where we have one angle congruent to one angle, another angle congruent to another angle, and the side in between them congruent. If that is true, then the two triangles are congruent. So it's another shortcut to knowing that the triangles are actually congruent. We only need to have angle side angle. Well, my video was too long, so I did not include example 1. I had to go back and edit this, so I can't include example 1. It's not going to be on the summative anyway. So if you want me to work through that problem with you at some point, I'm happy to do that, but it's not going to be included on the summative. Let's jump to example 2. Determine if you can use ASA to prove the triangle's congruent. Explain why or why not. So remember I told you that the reflexive property was going to be pretty important. We have a shared side here. That I know is congruent to itself. I don't know anything else about this shape. I know I have, for ASA, I have my angle that's, let me highlight this, my angle that they gave me that's congruent to the other angle, and this angle is congruent to this angle, but I don't have an included side. That's what's missing, is this included side. I do not know that those are congruent to each other, and that's the problem. So determine if you can use ASA. I cannot. I'm missing a congruent included side. Determine if you can use ASA to prove the triangle's congruent in my next one. Well, in this one, I know that I have two pairs of congruent angles. This one is congruent because it's a linear pair, and if one of them's 90, then the other must be 90 to add up to 180. So that's congruent. I also, again, I have my reflexive property. This side is congruent to itself by reflexive property. Super important. And so I actually do have, if I can highlight this, I have my angle congruent to one angle, my other angle congruent to another angle, and I do have my included side. So this follows, so I'll write it in green for you, not green highlighter, A. So yes, I have two congruent angles and an included side. Another shortcut is angle, angle, side congruence. This is where I'm given one angle congruent to an angle, another angle congruent to another angle, and then a side congruent to another side, not an included side. So if you notice, I'm starting at like point 1, making my way to point 2. I skipped over a side, and then I included the side. So angle, angle, side. All right, let's take a look at this proof. So first, let me write what was given. I know that angle X is congruent to angle V. Angle X is congruent to angle V. And I also know that angle YZW is congruent to angle YWZ. Okay, I'm going to stop there because I need to think to myself why they gave me that information. So I also noticed that angle XZY, angle XZY, and angle YZW are supplementary by the definition of supplementary angles. And just like that, I know that angle ZWY and angle YWV, marked by those red lines I just made, are also supplementary by the definition of supplementary angles. And I know that these angles must be congruent to each other, not congruent to the interior angle there, but congruent to each other, because think about this. If this one's 70 degrees, for instance, and this one must be 110, because they're a linear pair, right? If they're supplementary, they add up to 180. And if this is 70 degrees, because they're congruent, and then that one must be 110. So I know that angle XZY is congruent to angle VWY. Because angles, forgot the word that, angles that are congruent, no, not congruent, angles that are supplementary to congruent angles are congruent. Angles that are supplementary to congruent angles, the ones I marked with the blue, must be congruent. Okay, now that I know that, I have two angles that are congruent to each other now. That's a good start. Okay, and I have to go back to my given here, so I ran out of things to think about. So XY is congruent to VY. Let's take a look at that. XY is congruent to VY. And that was given. Okay, that helps a lot now, because now I have two angles and I have a congruent side. It's not, I have to be careful because a SA has two congruent angles and a congruent side, but I have to check the order. Is it ASA or AAS? So I have A and I skip a side, I go to another A, and then I go to the side. That's AAS. So I now know that triangle XYZ is congruent to triangle VYW by AAS. Okay, our next triangle congruence theorem shortcut is called HL. This is used for a right triangle. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. And it kind of makes sense why they named it this way, because we've got our angle that's congruent to each other and a side and then another side. And so if I name these right in order as angle, side, side, we kind of have a problem. We can't be writing that on the test. If you write that on the test, I'm assuming you're talking about me, and that's not going to be good. So make sure we're not using that. This would be the HL is what we call that instead. The triangles are congruent by HL, a hypotenuse and a leg. The hypotenuse is telling us already that we have that 90-degree angle, so it's got to be a right triangle if we're talking about a hypotenuse. Maybe I'll erase that word out of our notes here. But you get the idea. Okay, using HL to prove the triangles are congruent. So I'm taking a look first. First I need two right triangles. Well, I know that I have two right triangles because that's a linear pair. We talked about that in another problem already. So I've got my two right triangles. I know that the hypotenuse is congruent to the other hypotenuse because it tells me that. And so I'm missing a leg. I need one other leg congruent. Well, I have it because this is the reflexive property of congruence. So these are congruent to each other. And so it says, determine if we can use HL. The answer is yes. And my explanation is by the reflexive property in the linear pair that I've marked up on my image. Let's take a look at B. So we're talking about triangles, remember, so I can kind of ignore that rectangle in the middle. But I'm trying to see if I've got a hypotenuse that's congruent to each other. Well, first of all, I've got right triangles. That's a good start. And I don't know anything about this hypotenuse being congruent to that hypotenuse, so I'm missing my H. I do have an L, a leg, and a right angle. So I only have L. So I don't know if these triangles are congruent. I know I have a congruent leg of a right triangle, but I'm missing the congruent hypotenuse. Okay, now you try. So determine if we can use HL congruence stamp to prove the triangle's congruent. If not, tell what other information would be needed. I've got my two right triangles. I have the hypotenuse congruent. And I'm missing a leg, but I do have one leg congruent to another leg because of the reflexive property of congruence. So yes, these are congruent by HL.